Hello and welcome to XU Photography. My name is Daniel. Today we're going to take a look at my latest project. It's the Bubble Nebula, finally finished with the editing. But during the editing I find a curious nebula which I wasn't intend to photograph. It was quite hazy in the background and I tried to extract some more light, and it kind of looked like H.R. Giger's Alien. Really cool nebula, and it took me a while to understand what it was and in what catalog to be looking at. But bear with me, we're going to take a look at the Bubble Nebula and just a quick visit in PixInsight and how I edited this one. So stay tuned. The Bubble Nebula, or the NGC 7635, it actually is a bubble, an old star which exploded, threw away all the gas, and what is left is a vast cloud of gas, and in the middle it's the really nice bubble, which is absolutely amazing. But there's one perk in this image which I really want to talk to you about. So, but let's rewind and start off with when I gathered the luminance data. So I shot all the data from December to March, and it was a total of just under 1,000 sub exposures, 180 seconds exposures. So it's a vast amount of data, huge amount of data. And this is actually what it looks like straight out of the camera. No calibration, nothing at all. So this particular image we are looking at now is the sulfur image. Not really much to it. You can see some of the nebula in the middle here, but there's really nothing to enhance. Here we can clearly see the bubble. This is the O3 filter, the oxygen. And you can clearly start to see the structures just a little bit. Bear in mind this is just 180 seconds exposure. You can see the, I believe it's M52, the star cluster down in the corner. You can't see really much more than that. And here we are, the H alpha, and the H alpha images is always stronger in the signal. Then again, more details, a lot more details. And you can clearly see the gas around the bubble itself. And once again, the star cluster down here. But take a look at in this corner here. Going to do a preview. There is something there. And when I started processing this image, I hadn't a clue what this was going to turn out to be. I won't go through the details. I stacked the images. I calibrated the images with flats, darks, and bias. I believe the total amount of data I used for this image was about 16 hours worth of data, evenly distributed by H alpha, oxygen and sulfur. Out of the stack, this is the, as you can see on the file name at the top of the image, this is already this is the S2 filter. It's cropped and it's denoised with mer denoise. I also done a dynamic background extraction, but those images which has a lot of nebulosity in it might not always benefit from doing a dynamic background extraction. And we also made a deconvolution, which I covered in another video. You can watch it up here somewhere. I will link the video. So So let's just enhance this image, and this is the S2 data, and we can clearly see the star cluster down here starting to really come to life. We can also see some more details in the bubble, and we can start to see something going on up here. This is the finished S2 image. Let's take a look at the O3, and here we can clearly see the O3 data is really helping to enhance the bubble. The bubble itself contains a lot of oxygens. The field down here also really nice looking, and once again there is something there, but we can't really see it now. So that's the O3. And the H-alpha data, much more clean, and just such a big difference in signal to noise ratio. You can clearly see this image is way more clean than the other images. Less noise, nicer looking stars. They're really pinpoint after the deconvolution process. You can clearly see details in the bubble. There is something there, but we can see some of the nebulosity just around the star here. So yeah. Okay, so before I put all these images together, because of the huge difference in signal strength between the filters, I need to do a linear fit. I also covered that in the other video I made with the Elephant Trunk Nebula. But basically you're evening out the levels so that the proportions of the colors is correct. Then you combine the images to get an RGB image. And then you go over with histogram, just fine-tuning the image, and what you might end up with is this one. Just take a look at that bubble. I absolutely love how this image turned out. And let's just enhance that. So the star color is a bit off. It's narrowband, and I'm not that good at narrowband imaging yet. I'm starting to get a hang of it, and I really like how this image turned out. The M52, I think in the Messier 52 star cluster, just like a jewelry box. But let's take a look at that nebula. To me it looks like the Alien-nebula. Maybe not alien, maybe a skull, the Skull Nebula, I don't know. But this is actually called, I need to sheet now, Dobashi 3484. And that is what I found online. And it was quite tricky to get a hold of the information on what that was. So I couldn't find anything in the regular star charts. I downloaded some extra star charts for Stellarium, Cartesiel. I went online looking, but then I got some help from a Facebook group. So I haven't been paying notice on whatever might lie in the background of my images, but I will absolutely take a closer look from now on. You can also see in the right corner here, you can see a structure of some sort. But I will really take a closer look, because when I shoot so much amount of data, I can actually see some of the things laying in the background. I really hope you like this short video on the Bubble Nebula, which I am finally finished with, or actually the final version 2.0 well, you know how it goes. If you like these videos, please subscribe. If you're wondering about anything, just place a comment down below, and see you around. Take care. You've been watching Exo Photography. My name is Daniel.